Hello everyone, and welcome to the second theory prop video. Today we'll be talking about proving existence and non-existence. If you remember in the first video, we talked about how to prove a universal statement, which is a statement to the form, for any object with these properties, this other thing is true. Today we'll be talking about existence statements, which is to say that an object exists with these properties or an object doesn't exist with these properties. So here's an example statement, and to review from the last video. If you have a backwards E, that's mathematical shorthand for there exists. So you can think of this first part as saying there exists an n in remember this second symbol is the integers. So there exists an integer such that if we add 4 to it and square it, we'll get 0. And whenever you see an existence statement, often the best way to prove it is just to give an example, because if you give something where the properties are true, then you've proved that it exists because you just gave it. So here, we can see that n equals -4 is an example of an integer. And we have -4, and we add 4 to it, and we square it. Then we'll get 0 squared, which is just 0. So we've successfully given an example, and that completes the proof. So again, to review in general, when you see an existence statement that you're supposed to prove, you should give a construction that satisfies the theorem. And that will prove that it exists since you just made it. Non-existence can be a little bit trickier. So here's a similar statement, but it's a non-existent statement. So whenever you see a cross through the exist statement, it means there does not exist. So here we're saying there does not exist an integer such that when we add 4 to it and square it, we get -2. And this is a little bit trickier because we can't just give an example like we gave in the case of existence. So we have to think of some other way to do this problem. One idea, in sort of parallel fashion, might be we'll give a non-example. We'll give an example of a number that doesn't satisfy this. But that's not exactly what we're looking for, right? We're looking to say that no number satisfies this. And that sounds a little bit more like what we were doing with universal statements in the previous video. So actually suggest a reframing of this problem. Instead of saying there does not exist an integer such that this equation is true, we can prove for every integer this equation is not true, right? Those are the same thing. So to write it out in our for all notation, we can say for any integer, if we add 4 to it and square it, we do not get -2. That's the same thing as saying no integer, when you add 4 and square it, gives you -2. And now we have a much better idea of solving it because we have some ideas for how to solve or how to prove universal statements. And we'll do that below. I just moved to the next page so I can write this out in LaTeX. It's a little bit clearer. So again, remember the first step whenever we're trying to prove a universal statement is to fix an arbitrary integer in this case. And then we want to prove this second statement is true about the integer. So we'll observe that n plus 4 squared has to be greater than 0. That's a property of integers. When you square them, they are greater than 0. And then that means that we know n plus 4 squared is not equal to -2 since it's greater than 0. And that completes the proof. And since we prove this for all statements, in which we prove all integers, this property does not hold, that's the same thing as saying there doesn't exist an integer where the property does hold. So we've proved non-existence by proving a universal statement, which is often a good way to prove it. So those are the two important proof techniques from this video, which you guys will get to apply on the homework.